So, hello students. So, we have learned in the previous class how to find the square root by a long division method. We applied this method not only to find the square root of a perfect square number, we also applied the similar method or the same method to find the square root of a non-perfect square number. So today in this class, we will be learning some of the applications of the same. But before I start the class, I request all of you to watch the video till the end. As you know that due to the lockdown, we are unable to conduct the regular teaching and learning process. And this is the only way to continue the teaching learning process. But this effort of ours will only be successful if, being a student, you also take it seriously, watch the video, try to understand the video, and you solve the questions or the assignments that is assigned to you. Only then the teaching learning process through our online source can be considered to be a success. So please, all these videos, whichever will be uploaded to YouTube, it's for you. So do watch that video and do subscribe it so that whenever any new video is uploaded, you may not miss that. So anyway, now we'll begin our class today by solving some of the questions which applies the square root by a long division method. Right? Now in this topic, the first question what we will be solving is find the least number. Find the least number that must be subtracted from 796 to make it a perfect square number. Now this is the question. Now in this question, we are asked to find a least number which, when subtracted from 796, makes it a perfect square number, which clearly implies that 796 is not a perfect square number. But if any number or a minimum number is subtracted from this, it may turn out to be a perfect square number. Hence now, to find out what is that least number which needs to be subtracted, we'll try to find out the square root of 796 by a long division method. So for that, I will group this 796. And as you know, it is a whole number, it is an integral part. We'll group from left on, from right towards the left, this way. So this 96 will make one of the group, whereas 7 doesn't have a pair, so it makes one of the group. So what is a perfect square number closer to 7? 4. So 2 2's are 4. Now we'll add this 2 here, it makes up 4. We'll subtract 4 from 7, it makes 3. So it is 396. Now you know the procedure. We have 4, we add some number and multiply with the same number so as to reach closer to 396. So in this case, let me try adding 8. So I added 8, I multiplied with 8. 8 8s are 64. So I have written 4, 6 is carried over. 8 4s are 32 plus 6 is 38. So did we reach closer to 396? Yes. So we'll write 8 here, we'll write 8 here. it is 384. Now if you subtract this, 6 minus 4 gives me 2. 9 minus 8 gives me 12. Which means that this number is 12 more than the square of 28. Hence, to make this a perfect square number, what is to be subtracted? We have to subtract 12. It's because if you subtract 12 from 796, then the remaining number will be a perfect square number, and it will be a perfect square of 28. So therefore, number to be subtracted is, what is that number? 12. Now see, 796 minus 12, it will give me 487. What did you get when you subtracted the 12 from 796? You got 784. And this 784 is nothing but is the square of 28. Hence, here the number to be subtracted is always the remainder of this division. So this is how we solve this sort of questions. Now, this is one of the type what we have completed. Now we know how can we find out the number which is to be subtracted from the given number to make it a perfect square. Now the next question or next type, instead of subtracting, the question will ask you, find the least number that must be added. Next, there is a change in the word. Find the least number that must be added. To 511. So what is the number that I have taken here? 511 to make it a perfect square number. Now again the procedure is same. We will find the square root of 511 by a long division method. 511. So what is the first group? 11. Second, 5. So what is the perfect square number closer to 5? It is 2. 2 2s are 4. Now we add this 2 here, it makes it 4. 5 minus 4 is 1. Now we'll drop this group here, it becomes 111. Now if you add 2 and multiply with 2, 2 2s are 4, 2 4s are 8. Add this 2 here, this is 44, and we subtract here 7, 27. Now had the question been what must be subtracted, then the answer would have been 27. But here, the question is not asking us what we must subtract. It is asking us what we need to add. This means that this number 511 is lesser, it's more than the square of 22. Here 511 is more than 22 square. Am I right? It's more than 22 square. This clearly means if we add any number to 511, it gives us 23 square. Because the next perfect square apart from 22 square is 23 square. Hence, in order to get that number, we'll first find the square of 23. So what is the square of 23? 23 into 23. So I'll solve this way. 3 3s are 9. 3 2s are 6. Again, 2 3s are 6. 2 2s are 4. So 9, 2, 5. So what is that? The square of 23 is 529. So therefore, what is the number to be added? So the required number will be 529 minus 511. This will be equal to 18. Which means that if we add 18 to 511, then it will give us 529, which is a perfect square of 23. So this way now we can find out what is the least number that is required to be added in order to make the given number as a perfect square. So these are the two different types of application question we find in this section. So I hope you have understood, right? So it's clearly said here. So you can see here, if we add number to 511, it gives us 23 square. Is that okay? Okay, now with this we will end this topic here. Now I hope you can do all the questions which are similar to this. Now we will be learning about some of the properties of a square of a number. Right? We will learn today the properties of square numbers. Now please see, what are some of the properties of a square number? Property number 1. For all square numbers, if you take a square of any number, whether you take a square of 1, whether you take a square of 2, whether you take a square of 3, 4, 5, anything, for all the square numbers, ending digits will be either 0 or 1 or 4 or 5 or 6 or 9. So let me give you one example. Suppose I need to find the square of 5. What is 5 square? 25. What is the ending digit? Is it 5? Let me take a square of 4. What is the square of 4? 16. Is the ending digit 6? Let's take the square of 13. What is 13 square? 169. What is the ending digit? 9. Let us take square of 14 square. What is 14 square? 196. What is the ending digit? Okay, 6. Let us take an example. 19 square. What is the square of 19? 361. Again, see the ending digit. Is it 1? No, let me say square of 10. What is it? 100. What is the ending digit? 0. So whatever number you consider, if you take the square of that number, the ending digit will always be 0, 1, 4, 5, 6 or 9. So this clearly means that for any number to be a perfect square number, their last digit will be any of this. But this doesn't mean that every number that contains this in the last digit is a perfect square number. No. But if it is a perfect square number, then it will surely have this digit in the ending digit. So this is your property number 1. Now property number 2. A number having 2, 3, 7, 8 in the last digit is never a perfect square number. So if you consider any perfect square number, the perfect square number will have a digit like 0, 1, right? 4, 5, 6, 9. But if any of the number has 2, 3, 7 or 8 in the last digit, then it will never be a perfect square number. Which means the square of any number will never have a number with the last digit 2, 3, 7, 8. So this is your property number 2. So if I say 18, I don't need to take the prime factor to know whether it is a perfect square or not. What is the last digit? 8, so it is not a perfect square number. If I say 22, what is the last digit? 2, so not a perfect square number. If I write 27, what is the last digit? 7, it is not a perfect square number. So if any number has these numbers in the last digit, it will never be a perfect square number. Now property number 3. Number 3. If a number has 1 or 9 in its unit digit, then its square will have 1 in the unit digit. Now if you take any number, provided the number has either 1 or 9 in the end digit, then if you take the square of that number, the square of that number will always have 1 in the unit digit. That's it. Let me say 21 square. 21 square. Now this number has 1 in the unit digit. I took the square of this number. It will give me 441. Now see, what does the last digit have? Again 1. If you take 19, now I have 9 in the end digit. So if I take the square of this will give me 361. Let me say I took 9 square. It will result into 81. If you take 11 square, it will result into 121. Now for all this number, the end digits are either 1 or 9. But when I took the square of such numbers, the end digit of all those numbers are 1. This clearly means that if a number has 1 or 9 in its unit digit, then its square will always have 1 in the unit digit. Similarly, number 4. In property number 4, if a number has 4 or 6, what is it? If a number has 4 or 6 in its unit digit, then its square will always have 6 in the unit digit. So let me illustrate this with an example. 4 square, 16. 6 square, 36. 14 square, 196. 16 square, 256. Again, see the pattern. When I have 4 and 6 in the unit digit, and if I take the square of that, the resultant answer will always possess 6 in the unit digit. It is same as the previous one. But in the previous one, if the number has 1 or 9 in its unit digit, then the square will always have 1 in the unit digit. In the same manner, if a number has 4 and 6 in its unit digit, then the resultant will always have 6 in the unit digit. So this is your property number 4. So these are some of the properties which is very important. Actually, this property will enable us to know the answer in a very short duration, where we do not have to do the long calculations at all. Just by looking at the number, we can say whether it is this or not. Now, property number 5. If a number ends with n zeros, if any number has n number of zeros, n number is 1, 2, 3, 4, right? If a number ends with n zeros, then the square of that number, will end with 2n zeros. Now what does this mean? This means that the number of zeros in the result will always be double than the number of zeros that is there in the question, whenever we find the square of that number. So let me try to illustrate this with the help of an example. Let me say 30. Now in this 30, how many zeros do I have at the end? 1. Now if I take a square, what is the square of 3? 9. That if there is 1 zero, the result will have double of that. So it is 900. Similarly, suppose, let me say I have a number 160. Right? Okay. Let me say I have 1600. 1600. Now if you keep multiplying, will that be difficult or not? Yes? It will be time consuming. But if you know this property, we don't need to multiply. See here. If I take the square of this, just focus on a number. What is the number that we have? 16. So what is the square of 16? 256. Now as per the property, in the question we have 2 zeros. Then obviously the resultant will have the zeros double of this. So there will be how many zeros? 4 zeros. So this property is very important because it will help us to minimize our effort. Because we do not need to do a long calculation of multiplying. Okay? Now, the next property, that is property number 6. What is that? Property number 6, I guess. Now in this property, for any natural number, n plus 1 whole square minus n square, where n can be any number, it can be 1, 2, 3, 4. Okay, you don't have to worry about that. For n plus 1 whole square minus n square, this always is equal to n plus 1 plus n. What is it? N plus 1 plus n. So what does this mean? Let's say n is equals to 5. What do I have n? 5. So 5 plus 1 whole square minus 5 square. Right? So what is my n here? 5. So 5 plus 1 whole square minus 5 square. What does it give me? See here, I'll solve from both the ends. 5 plus 1, 6 square minus 5 square. 6 square is 36 minus 25. So what do I have here? 11. Now, instead of finding the square, if I know this property, I know my n is 5. So 5 plus 1 plus 5. See here, is this 11 as well or not? So Pythagorean triplets. Now what are Pythagorean triplets? Have you heard about this now? No. Yes, very good. These Pythagorean triplets are the 3 numbers. Let's say P, Q and R are 3 numbers. If P square is equals to Q square plus R square, or Q square will be equal to P square plus R square, or r square is equal to p square plus q square, which means that if the square of one of the number is equal to the sum of the square of the other two, then such number forms the Pythagorean triplet. So the most common one is 3, 4, 5. Now if you take the square of 3, what is it? 9. If you take the square of 4, what is it? 16. If you take the square of 5, it's 25. Now see here, 3 square plus 4 square, is it equals to 5 square or not? 3 square plus 4 square, 9 plus 16, is it 25? And is 5 square 25? Are they equal? Yes. This means 3, 4 and 5 forms the Pythagorean triplets. So basically a Pythagorean triplet, these are the 3 unknown numbers, right? But the square of one of the number is always equal to the sum of the square of the other two. Can you name some more Pythagorean triplets? If yes, do it. So today, we'll end this topic here. With the end of this topic, we'll end this chapter as well. Now it's your duty, it's your responsibility to learn and practice this chapter. Thank you very much. Class 8. In the next class, we may start a new chapter, that is cube and cube.